All right, let's talk about something super cool. The secret language that robots use to communicate. It's called the Robot Operating System, or ROS for short. And it's the brain behind everything from those little hobby bots you see online to the massive arms in a factory. But what is it really? Let's dive in and demystify this thing.
Okay, so the very first thing we need to get straight about ROS is that its name, well, it's a little misleading. When you hear operating system, your brain probably jumps straight to Windows or Mac OS, right? The thing that runs your computer. Well, with ROS, that's not what's going on at all.
Yep, that's right. Despite the name, ROS is not a true operating system. It doesn't handle all the basic stuff on your computer. Instead, it's what we call an open source framework. Think of it as a giant toolbox or a set of rules and helpers specifically designed to make building robot software way, way easier.
So if it's not an OS, what is it? Well, the technical term is middleware. And what that really means is it's like a special layer of software that sits between the robot's actual operating system and all the different programs running on it. Its main job is to help all those different parts talk to each other without any drama.
You know what? I think an analogy will really help here. Just picture ROS as a kind of universal translator, or even better, a super efficient postal service built just for robots. It's not writing the mail, and it's not reading it. It's just the expert at making sure every single message, every piece of data, gets exactly where it needs to go, no fuss.
Okay, this postal service analogy, it's actually the perfect way to understand the nuts and bolts of how ROS works. So let's really break this down.
So, in the world of ROS, every independent little program is called a node. A node could be the piece of software that's just reading data from a camera, or another one that's controlling a motor. Maybe a third one is running a complex algorithm to figure out where to go. Each one is its own separate thing.
So, if we stick with our postal service analogy, a node is basically like a person or a specific department in an office. It's an endpoint, you know? It's someone who can send mail out and also receive mail. Pretty straightforward. But wait, how do these nodes actually send messages back and forth? They can't just shout into the digital void and hope for the best? Nope. They communicate using specific channels, and in ROS, these channels are called topics.
And boom, we're back to our analogy. If a node is the person or the office, then a topic is their specific mailing address, like a PO box. So when one node wants to send out, say, information from the camera, it sends that message to the camera_data topic. Any other node that cares about camera data knows exactly which address to check for new mail.
Now, this whole system, this idea of sending messages to a specific address for anyone who's interested to pick up, this is actually a famous concept in software called the publish-subscribe model. And this model right here is the engine that makes ROS so incredibly powerful and flexible.
So here's how it works, in 3 easy steps. First, a node, let's say it's our camera node, publishes a message. It's basically sending a letter. Second, that message goes to a specific topic, like the camera_image PO box. And third, any other node that needs that info, like the navigation system, subscribes to that topic. It's essentially telling the post office, hey, let me know whenever new mail arrives at this address.
And the real magic of this whole publish/subscribe thing is just how flexible and scalable it is. Think about it. You can add a brand new sensor to your robot, and all it needs to do is start publishing to the right topic. You don't have to rewrite a bunch of code. The different parts of the robot don't even have to know about each other's existence. They just care about the mailboxes.
All right, so we've gotten into the technical details of how it all works. But why does any of this matter? Let's zoom out and look at the big picture for a second.
This is a huge deal, because ROS gives you a whole suite of core services right out of the box. We already covered the flexible communication, but it also gives you hardware abstraction, which is a fancy way of saying you don't have to write totally different code for every single brand of camera or sensor out there. It handles low-level device control, package management. ROS takes care of all the tedious foundational plumbing, so developers can get straight to the fun part, building cool robot behaviors.
So what's the ultimate takeaway here? It's this. ROS creates a common language, a standardized way for robot components to talk. And because of that, developers don't have to reinvent the wheel every single time. They can build insanely complex robots by mixing and matching these reusable, independent modules. It's a total game changer.
And that really brings us to a final, pretty mind-blowing thought. We've seen how ROS has created this common language that has totally turbocharged robotics development. So let me leave you with this question. If all robots could speak the same language, what new possibilities would that open up? What could we achieve in a world where robots could truly collaborate and learn from each other?